So we throw 5.5 in. It's, a lot of the stuff's in chapter 4, but when we throw the 5.5 stuff in, it's building inverse functions. So basically, when you think about mathematics, if you're solving equations, you do, like the other day, we solved all those equations. We're using inverse operations to undo things. So if the equation has adding and you subtract on both sides, it undoes the adding. And so an inverse function, basically, there are a bunch of different things you can write down for it. Your domain and your range change places, and so the idea is your x's and y's switch, your outputs and inputs switch, and all they do is trade place with each other. Inverse notation, if you see somebody write down f to the -1 of x, that's the notation we'll use for inverse. That will represent the inverse function. In the box, it talks about how you can do this work. Interchange the x and y in an equation and then solve back for the y. Or do the opposite of each operation in the reverse order. And you'll see what we're talking about. So one of the first things I would do, remember f of x is just a fancy way to write, it's function notation. So the first thing I would do is write y equals -5 plus 4x. So in the box just above it, it says exchange x's, y's. So make this y become an x. Make this x become a y. Now we solve for y, and we'll have our new inverse function. So we can add 5 on both sides. So x plus 5 is equal to 4y, and divide by 4 on both sides. And I end up with, I'm going to write it up here, y equals x plus 5 over 4. But that's an inverse function, so that nobody's confused. Let's write it with the inverse notation, f inverse x plus 5 over 4. Now in pre-calc, we make students verify it, and you would do the work there, but right now we're not going to make you verify it. So on the next one, with somebody sitting near you, let's write down y equals the square root of x divided by 5. I'll pause it for just a second. You can work on it, see if you can come up with the inverse. So I left you when we had the y equals the square root of x over 5. The inverse function, we want to exchange x's and y's, and then solve for y again. So to get rid of the square root, you can square both sides and you get x squared is equal to y over 5. Then you can turn around and multiply both sides by 5. And it's x squared times 5, or 5x squared. So if that's your function, I guess your inverse, then we can write it in the notation. The inverse then is 5x squared. So first step should be something with the f of x. Let's write a y equals, flip-flop your x's and y's, and then solve for y again, and you'll have it. Now, on a problem down here, quote-unquote, real-world application, right? It's a word problem. Celsius is 5 times the degrees Fahrenheit minus 32 degrees, all divided by 9. So if I, travel outside of the country and I'm used to degrees Fahrenheit, I can plug something in and figure out what it is in degrees Celsius. So that's what this problem is talking about. In the box here though, they talk about when you find an inverse for real world problems, if you start switching your C's and your F's and solving back for the other one, it gets very confusing as to what you have. So in this case, we're not going to do that. We're just going to leave the variables where they are and try to find the inverse by solving for the other variable. So we're going to slowly peel things away, and instead of having C equals, we're going to go the other direction and get F equals. So what's the first thing we can do? Yeah, you can distribute. There will be nothing wrong with that. I'm not going to. Just thinking ahead. I'm going to multiply by the 9 first. It's a little bit easier for us to see it that way. Now, some of you might have even taken this as 5/9. How can you get rid of 5/9 at one time? Multiply by its reciprocal. Because now, this is why I didn't distribute. I'm going to divide by 5. And so ultimately, we end up with 9/5 C equals F minus 32. And then the last step we have to do, add 32 on both sides. And so your Fahrenheit equation then is 9/5 of C plus 32. Okay? So those are the two equations. Those are inverse of each other. So hopefully you're seeing the two different methods. One of them we did an exchange. It's easy, but here if you start switching your F's and C's around, it will not make sense when you're done. So don't do that. You can model the time t in seconds it takes for a falling object to reach the ground from height h in meters. So the function's over there, t equals the square root of 2h divided by 9.8. Write a function to determine the height of an object if you know the time it takes for the object to hit the ground. So what do they want you to do? Right? Solve for t. So do that now, solve that for h. Solve that equation for h quickly. Show the person sitting next to you what you get. So if we start over there, you could square both sides. That gets rid of the square root. Multiply both sides by 9.8. And then the last thing would be to divide by 2. Now, depending on what you did, right, you can take 9.8 divided by 2, what do you get? So you can write it as 4.9 t squared is equal to h if you like. Yes or no? So if you drop an object from the top of the IDS building in Minneapolis, it'll take 7 seconds to hit the ground. What is the height of the building in meters? So take that 7 seconds, and you can put it right there. So what's 4.9 times 7 squared? Two. 40.1. Now remember up here, this is in meters. About 240 meters tall. Method 2 of building an inverse. Interchange the x and y coordinates of an ordered pair, reflect each point or part over the graph y equals x. Okay. Sometimes we don't know what the equation is, all we have is a picture of the graph. And literally all you do is flip-flop x's and y's. So determine the inverse of the function consisting of the following points. So I'm going to start by putting blue dots on the graph. So if you have two colored pens or something, you might want to do that. But 2, 4 would be 1, 2, 1, 2, 3, 4. 3, 8. 1, 2, 3, 1, 2, 3, 4, 12. And 0, -4. So those are my blue dots, right? Now, let's see if I can get a straight line on here. Now I'm going to look at the inverse. So these will be red dots. So all I'm doing is flip-flopping the x's and y's. The x's become y's, y's become x's. And we graph them now 4, 2. 1, 2, 3, 4, 1, 2. 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 12, 4. 10, 11, 12. 1, 2, 3, 4. And -4, 0. 1, 2, 3, 4. Right there. And then again, I'll put a straight line on those. So that's what my graph is looking like. Any questions on how we drew that inverse? Now it's telling you graph the y equals x line. So if I go back, I'm going to put it in yellow. It probably won't be the easiest to see, but when you draw that y equals x line, notice how the red and the blue are symmetrical over the yellow line. In other words, if we fold it on that line, they're equally spaced here at these two dots, equally spaced at these two dots, same there, and the last set. That is not a mathematically correct way to verify results, but if you guys ever have two equations and you're not sure if you have the right inverse, you can graph them, draw the y equals x line in there, and it'll give you an idea that you're correct or not. So what they want us to do is just quickly look at it. What does it look like when you do the calculator? So we're going to do y equals 2x cubed on the calculator. So if I find that inverse, I need to solve for y. So I switch my x's and y's around. I can divide by 2 on both sides. How do you get rid of a cubed? You cube root. And so I should be looking at the cube root of x divided by 2. So go to y equals screen, and the first one is 2x cubed. To do a cube root, the easiest way is probably to put whatever was inside the cube root, the x divided by 2, put that in parentheses, x divided by 2, and raise that to the 1 divided by 3 power. Now my calculator puts like the subscript in there and it goes up there, and if some of you hit the caret symbol, the raised to, and it doesn't do anything, like you just keep going, make sure you put parentheses around 1/3. So some of you may have to type it in as y equals x divided by 2 caret parentheses 1 divided by 3. Anyway, when we go to graph this, a couple of S-shaped curves, slightly stretched, and then what they're saying is go ahead and graph the y equals x line. And so do you see the symmetry that's on either side of that? Like if you folded it, when you're a little kid, the butterfly appears. Yeah? It's not the best way to do it, but it gives you an idea. So when you guys get to the exam, and the problem is, here's your function, find its inverse, and you find it, you're not always 100% sure if you're right. Type the two functions in, put the y equals x line on there, and see if it looks good.